All right, this is our second video on the Newton's second law. So Newton's second law is F equals ma. And I remember when I was taking my physics courses when I was your age or when I was in college, and I just really thought that the law was just really the equation. And actually, it's more than just the equation. The law is pretty much talking about the proportional relationship between a force and a mass and acceleration and a force. So we see here in this equation here that the force is directly proportional to the mass. So that means that if I have a very big object, it has the potential to have a very big force if accelerated. If I have a very small object, it has the potential to have a very small force if accelerated. And there's also a direct proportional relationship between A and force, meaning that if I accelerate an object with a very high acceleration, it's going to have a big force. Vice versa, if I decelerate an object, the force is going to be not decelerated, but if I decrease the acceleration of it, it's going to have a very small force. All right, so it's pretty much just showing the linear relationship between mass and force and acceleration and force. All right, and so as you see here, once we start calculating the force from the thruster of an airplane, you'll see how the force is directly related to the acceleration of the airplane. And you'll see how it goes up and it goes down. All right. So let's say if I have a airplane here and the mass of the airplane is 2 kilograms. Okay. So the way that I'm going to find the acceleration is I'm going to use a program from hyperphysics. Because acceleration, it's really hard to find if you don't have like a motion sensor or if you don't have some type of computer that can do it for you. The answer is it won't be accurate. All right. So the first thing I'm going to do, I'm going to establish 2 points. I'm going to start the airplane at 1 meter. All right. And point 0.1 meter. And I'm going to say that the airplane goes from 0.1 meter to 0.2 meters. Okay, so that is a displacement of 1.1 meter. All right, and so I'm going to put that in my computer. So the distance traveled was 0.1 meter. So it went from 0.1 to 0.2. And let's say it has a time displacement of 3 seconds. Okay. So the acceleration is going to be when I put in my time here, 3 seconds, the acceleration is 0.02 meters per second squared. So my acceleration is 0.02 repeating meters per second squared. Okay. Now we can go ahead and calculate the force applied from this airplane when it went that displacement. So it's going to be F equals 2 times 0.02. That is my mass. 0.02 is my acceleration. The force is going to be two times 0.02, 0.04 newtons. So that is the force, 0.04 newtons. Okay. All right, let's do it again. So let's say we start from 1 and we go to 3.3 meters. And it does that displacement in also 3 seconds. All right, so we're going to put that. So the displacement, it goes from 0.1 to 0.3. So that's going to be 0.2 displacement. 0.2, and it does it also in 0 seconds. The acceleration is 0.01. 0.01. And therefore the force is going to be 2 times 0.01. And that's going to equal 0.02 newtons. All right, so now let's go ahead and do it again. So we're going to go from 0.01 meters all the way to 0.5 meters. All right, so that is a displacement of 0.04 meters. And let's say he does this in 10 seconds. Okay, so we're going to put that in our calculator. So it was 0.4, and he does it in 10 seconds. The acceleration is 0.008 meters per second. Meters per second squared. All right, and so therefore the force is going to be F equals 2 times 0.008 meters per second squared. 2 times 0.008 meters per second squared. 0.016 newtons. 0.016 newtons. Okay. All right, and let's do one more. We're going to go from 0.1 meters all the way to 0.9 meters. And let's say it does that in 15 seconds. All right, so the acceleration is going to be 0.15 seconds. .007 meters per second. All right, Schultz. Take it easy. All right. So force is going to equal 2 times 0.007 meters per second. And that's going to be 0.014 newtons. So we can see the linear relationship here, that when we have a much bigger acceleration, the force is also big. But then when we have a very small acceleration, the force gets really small. And so that's the relationship between acceleration and force. Now, if I were to change the mass, you'll also see how the force will also go up or go down. So it's just a linear relationship. That's what Newton's second law is saying, that if the force goes up, it's going to probably have a big mass. If the acceleration goes up, it's probably going to have a big force. If the mass goes up, it's probably going to have a big force, vice versa. All right. Thank you.